So there are various types of languages. We have discussed this before. There are compiler languages, languages that can be compiled, and then there are interpreted languages. This was the thing that we discussed initially. JavaScript is an interpreted language. Similarly, there are what are called strongly typed languages and loosely typed languages. This is another distinction you can make in languages, what type of language something is. For example, C++, Java, C, and Rust are what are called strongly typed languages. And Python, JavaScript, and a bunch of others that I just Googled, if I'm being honest. I know PHP, but like Perl, something I just Googled. What are loosely typed languages? Python and JavaScript are the popular loosely typed languages. What does loosely and strongly even mean? Let's look at the code on the left and on the right. This is some basic C++ code. If you don't understand it, it's fine. The goal to look at is, okay, I have defined number as an integer here. So you have to give the type of a variable when you're defining it. Versus here in JavaScript, you can simply be like, let number equal to 10. In JavaScript, you can also change the type of this number to string. You can be like number equal to text or an object or an array, whatever you want. As long as this is a let and not a const, you can change not just the value, but also the type of the variable. This code will work. The code on the left will not work. If you try to run this C++ code, which you can run locally on your machine, or you can run on Replit, some online compiler, either way, you will notice this code does not work. It will give you an error that is on the lines of, okay, you're trying to assign number to a string, but number is defined as an integer. You have specifically defined the type of this variable, number, okay, it is an integer. You cannot assign it to a string or an object or anything else. That's the difference between strongly typed languages and loosely typed languages. Examples are these and these. What are the benefits of using a strongly typed language? Which is a better one, Vaisi? Can you guess? When you're starting out coding, loosely typed languages are slightly better because they are easier to write code in, faster to bootstrap. You can quickly start and get your project up and running. You don't have to worry about types. And there is a lower learning curve. Basically, when you're starting your programming journey, it's good for you to get dopamine hits and not get stuck on type errors like these. So it's good for you to use a loosely typed language. But you, as time goes by, in production, in big companies, you want very strict type checking. Why? Because developers are dumb and can make mistakes like these. If a variable is called number, probably shouldn't be assigned to a string, but a developer is dumb. Developer can write any code they want. Here, the compiler will help them and tell them, okay, bro, there is a problem in your code most probably. Here, the same thing won't happen, which is why ideally in production in the real world, people prefer strongly typed languages. This is why people keep saying, okay, Rust is the future, or Java is better than JavaScript, because there are less runtime errors. What are runtime errors? Okay, bhai, when the code actually runs, this line runs, there won't be an error. The error is caught at compile time. When this code is getting compiled, then the compiler will tell you, bro, there is some type issue here. I will not compile this code. Versus here, the code starts running. There is a runtime error, if at all. Here, of course, there won't be any error because JavaScript is like, kar lo jo karna hai. Like, do whatever you want. But if you try to, do some number operation here, assume this was a number, then JavaScript might throw an error, which will be a runtime error. Here, there are lesser runtime errors because you catch all the errors during compilation, during when this code is being converted to bytes. Stricter code base, you cannot write dumb things like these. Your tests will fail, or more specifically, compilation will fail. So you will know there is an issue there. And lastly, easy to catch errors at compile time. So Rust may, people say, this is sort of true only. If you start to write code, you will find 100 compile time errors when you try to compile your code. But once you get rid of all of them, you will notice by the end that the code does what it was expected to do. It is such a strict language. Okay, even if you try to do something like this, it will complain. You try to do something else also, it will complain. So, you have to write code in such a strict manner. Okay, by the end of it, if it compiles, it will most probably do what it was supposed to do. So what are two types of languages? Strongly and loosely typed. What is JavaScript? JavaScript is loosely typed. And people realize this is not great. JavaScript is a great language for 1,000 reasons, but since it does not have types, it does not have these benefits. So people said, let's add these benefits to it and introduced TypeScript. People realized that JavaScript is a powerful language, but lacks types. What do I mean when I say types? This thing right here. Here you can define that this number is an integer. Here you cannot define that number is, an integer. It's let, could be anything. TypeScript was introduced as a new language to add types on top of JavaScript. Cool. Let's go to the next slide. What is TypeScript? TypeScript is a programming language developed by and maintained by Microsoft. It is a strict syntactical superset of JavaScript and adds optional static typing on the language. What is static typing? We'll get to. Basically, the thing that we saw in the last slide in C++, providing types to variable is what TypeScript gives to JavaScript. If you look at it, TypeScript is a superset of JavaScript, which basically means if you write some JavaScript code, it will work in TypeScript. If you write some TypeScript code, it will not work in JavaScript. TypeScript, you can write simple JavaScript syntax. You can write some extra things on top, types, which we will see very soon. But a natively available JavaScript code base that you might have will almost certainly just work in TypeScript if you don't have very strict compilation checks. If you have a JavaScript code, you can just change the file extension from .js to .ts and you're good to go because TypeScript is backward compatible. TypeScript is like, okay, normal JS code works. I will give you something extra on top. How does the TypeScript code run? This is super important. This is, one popular interview question, good thing to know, high focus required at this point. TypeScript code never runs in your browser. Your browser can only understand JavaScript. TypeScript is a totally new language. That is not the language that ever runs in your browser. That is even not the language that your Node.js runtime is able to run. In fact, TypeScript never runs at all. I repeat, TypeScript, if you write some TypeScript code, it never runs at all from line to line. JavaScript is the runtime language. TypeScript is something that gets compiled down to JavaScript. If you understand this line, you are good. But this is an important line. TypeScript is something that gets not exactly compiled. It's called transpiled. Transpiled down to JavaScript. Basically, if you have a .ts file, a TypeScript file called main.ts, you can run a command to convert this TypeScript file into JavaScript. And if there are any type errors here, if you have done anything ugly that, the TypeScript compiler can check, for example, given a type and then changed it to string, given a type as an integer, changed it to string, that's the same thing we saw in the last slide, TypeScript compiler will be like, I am not creating JavaScript file. It will do all the static type checks. Have you done things the right way? And if you have, it will give you a JavaScript file, which then runs in the browser and the Node.js. So this file never runs. You never execute TypeScript code. You only convert TypeScript code into JavaScript code using this command or some other command. And what is this command supposed to do? What is the TypeScript compiler supposed to do? It is supposed to ensure that there are no type errors in your code. There are no errors similar to the errors that we saw in the last slide. If you've defined something as an integer in TypeScript, you should not assign it as a string. These are the checks that it does. And if everything checks out, creates a JavaScript file, doesn't check out, does not create the JavaScript file, never runs in the browser, never runs in Node.js, this is what always finally runs. In the end, you have a simple JavaScript file only. When TypeScript is compiled down to JavaScript, you get type checking similar to C++. If there is an error, the conversion to JavaScript fails. All right. So this command will only proceed and run well if you've written right code. If you have any error in your code, it will fail during compilation. Can you see now that we've added compile time checks to JavaScript, or more specifically TypeScript? Okay. This was a language where only runtime errors were thrown. Now you can catch these errors during compilation. Very similar to C++. When the code is getting converted from C++ to bytes, you can catch some errors. Similarly now, when the code is getting converted from TypeScript to JavaScript, you can catch some errors now. TypeScript is not something that runs. I'm repeating this. If I go to chat.openai.com and write, give me a function that gives me sum of two numbers, it gives me a JavaScript file. Similarly, if I write some TypeScript code and run this command, it gives me a JavaScript file. This file is actually what runs in the browser and Node.js. The TypeScript compiler, this TSC thing that I wrote here, TSC is the official TypeScript compiler that lets you convert TypeScript to JavaScript. There are many other famous versions of this, variations of this that let you do the same thing. Some important popular ones are ESBuild and SWC. There are a bunch of others. Cool. Which will we use today? The official TypeScript compiler. All right. Cool. That's a brief of language, what it does. Until we write code, we'll not learn anything. So now I would urge you to do one of two things. Either go to Replit and create a TypeScript playground, or in your machine, install TypeScript globally. So you can run npm install -g TypeScript to install TypeScript locally on your machine. If you are facing any issues, you can just go to Replit for now and create a fresh TypeScript REPL to practice all we're doing today. I'm going to give you guys, let's say, a minute to do it. I'm going to do the same thing. Basically follow all the instructions here if you want to do it locally. If not, open a TypeScript playground on Replit so you can test everything here. All right. First command to run. npm install -g TypeScript. Second command to run, create a node-app folder. Go into the node-app folder and run npm init-y. This will do what? Create a package.json file. Then run either tsc-init or npx tsc-init. Both of these should work. Either tsc-init or npx tsc-init. At this point, if you face an error that says the TypeScript version is not correct, you don't have the right version of TypeScript installed locally, is when I would urge you to just go to Replit for now and eventually fix that error. It's a very popular error that might come based on the node version you are in, if you've installed TypeScript in the past, if you've not installed it locally, globally, but locally. So if you see an error when you run this command or this command, then move to Replit. If not, by this point, you should see two files in your code base, a package.json and a tsconfig.json. Open this up in Visual Studio Code. I'm going to give you guys 20 more seconds to do this. Try it out. By the end, you should have package.json and tsconfig.json. Test between npm and npx. npm lets you install modules. npx stands for node package executable. It lets you run a package without, officially installing it. That's a high level. All right. Seems like most people have been able to do it. So let me go back to the slides here. 10 more seconds and then we'll proceed. All right. So now you have these two files. Until now, we only ran the first command when we were starting a Node.js project. We only added a package.json file. Now, if you want to use TypeScript, you have to create another file called tsconfig.json. This file contains a bunch of, call them configurations, bunch of variables that you can turn as true or false. And based on that, your compilation process will change. I repeat, how your TypeScript code gets converted to JavaScript will change based on how you tweak these parameters. There are a lot of these here. Even I don't know all of these, but we'll get to some popular ones that you can make some sense of. Acha, this means this, this means this. But this file, what does it contain? It contains a bunch of configurations. Okay, how do you want to convert your TypeScript file to JavaScript file? What does package.json contain? It contains the dependencies that you have, which right now we have none, the name of the project, version, description, so on and so forth. This we've done a few times now. Hope you understand. Package.json has nothing to do with TypeScript. This tsconfig, as the name suggests, is the config of your TypeScript code. Next thing I would urge you to do is create a new file here and call it a.ts, not js, ts. Give it a .TypeScript extension, and then let's write some code inside here. To kick things off, write this code in there. Const x : number equal to 1, console.log x. after you write this code, you will notice there are no red squigglies, everything looks fine, and you have a basic code that you would write. If you were writing it in JavaScript, how would you write it? Const x equal to 1, console.log x. If you're writing it in TypeScript, you are giving an explicit type. Okay, bhai, this x is a number. Similar to in C++, you write this int x equal to 1. So just how you give a type to a variable in C++, in TypeScript, whenever you're defining a variable, you give it a type like this, const x colon number. Okay, bhai, this thing is a number, the value of which is 1, 2, 3, whatever you want to give. All right, going to give you guys 10 seconds to write this code on yourself and marinate it. The only extra thing is this part right here, how to give the type to a variable. Next up, open the terminal and see if you have the tsc command. If you do, run tsc space -b. If you don't, then npm install -g TypeScript followed by tsc space -b. This will convert your TypeScript code to JavaScript. If you look at the file structure now, you will see a newly generated a.js file. Give you guys 10 seconds to do it. What is the command? tsc space -b. What is the file that you created? a.ts. What is the file that the TypeScript compiler created? a.js. 5 more seconds. Explore the a.js file. Notice it does not have a colon number here. It went away. Why? Because this is not a TypeScript file. The final file that is created, the final file that you always run, is the JavaScript file. TypeScript is just a syntactical language that gets compiled down to JavaScript. That is exactly what happened here. And if I want to actually run my code, what will I run? Will I run node a.ts or a.js? I will run node a.js because that is the final thing that my browser is able to run or my Node.js runtime is able to run. Node.js runtime does not understand what is this colon, what is this number. Only the TypeScript compiler does. Cool. So write this out, explore this. Going to give you guys 10 seconds and then we will proceed. Cool. So what have we done? Created an a.ts file, given a type to x, compiled it down, and we finally saw the TypeScript file got converted to a simple JavaScript file. Harkirat, what is used strict? Something that JavaScript makes your code checking a little more strict. Usually, rule of thumb, you never have to look at the final a.js file. As time goes by, this is a very simple thing, but as we create more complex applications, this gets super ugly because this is something that the compiler has written, not a human. So this file will have a lot of very minified, uglified code, which you don't have to look at ever. Just for now, we are looking at, this is how the JavaScript code looks like given the original TypeScript code. Notice how there is no TypeScript code in the JavaScript file. It's just plain old JavaScript with no types. Now, delete a.js and add some sort of an error in your TypeScript file. Introduce anything that is incorrect. For example, if you do a x equal to Harkirat here, this is incorrect. We now have a strictly typed code base. TypeScript is strictly typed. JavaScript is loosely typed, but TypeScript is strictly typed. You cannot do this in TypeScript. In fact, if you try to do this, it gives you an error. Oh, the error is something else. It's because this is a constant. Let's make this a let. It still gives you an error. String is not assignable to number. This is where the power of TypeScript comes into the picture. Okay, now if you try to write ugly code, TypeScript compiler is complaining. If you try to convert this ugly code into JavaScript, TypeScript compiler says, sorry, type string is not assignable to number. Found one error. I am not going to create the final a.js file. You have an error in your code base. This is the benefit of TypeScript. It adds type safety to your JavaScript code, which is something JavaScript does not natively support, but someone created a new language on top that lets you add type safety to it. This is the reason it is used everywhere in most code bases. 99.9% of the code bases you will see this. Why? Because as developers, we are very dumb. As the project becomes very big, you will do dumb things like these. Okay, number you will assign as a string. So to fix that, you add type checking, very strict type checking through your code base, so that even if you miss something, TypeScript compiler catches it for you. All right, try to run this code locally, add some sort of a different error, try to assign this to an object. Error will remain the same. Okay, you cannot assign this thing to the type number. Cool. Anything else here? No. That's all for this slide. Let me do a quick poll, even though I'm hoping everything is pretty straightforward here. 92% is great. Happy to look at questions at the end of the class. I was just warming up right now. Just understanding the syntax of TypeScript. The only thing to learn until this point is number one, how to initialize a TypeScript project, which if you haven't been able to, go to Replit and run the same code. Number two, how to convert the TypeScript code into JavaScript code by running this command. If you're on Replit, this will be a little hard, but just try to write the code on Replit if you're not able to follow along locally. Let's move on to the third slide. Sorry, fourth one. Yeah, fourth one. Basic types in TypeScript. So let's now write some more code. We've written a very basic code and understood how to assign number to a variable, the number type. There are a bunch of other common types in TypeScript: number, string, boolean, null, undefined. Let's create a few applications to understand these types better. Number one, the hello world program. Things to learn: how to give types to arguments of a function. Now, I would urge you to write a function where the function's arguments need to have types. Write a function that greets a user given their first name. Argument, there's this one argument called first name. It should log hello first name on the screen and should not return anything. Try to write this code, maybe even without TypeScript. Just write a simple function in your a.ts file called, or you can call it whatever you want, I guess. I'm going to call it greet, which takes first name as an input and then simply logs hello first name. This is how you would write the code base if this was a JavaScript project. Let me also call this function. Take 20 seconds to write this code on your side. There is also a solution here, so you can just copy it from here as well. This is the final solution. This is not the final solution. This is how you would write the same thing in JavaScript. If you want to convert it to TypeScript, is when you have to add something extra, which you guys can already see here. Okay, the argument needs to have a type. That's what the error is here right now. But first write this much code and then we'll go there. 10 more seconds. All right. What does it say? It says parameter first name implicitly has an any type. Basically means you've not given it a type. It implicitly by default it can be anything. We don't support that. TypeScript is like, I am a very strict compiler. You need to give it a type. It cannot implicitly be any. What is any? Just like, number is a type, string is a type, any is also a type, which means this can be anything. So you can also always do const x colon any equal to 1. And what is the error saying? It is saying first name is implicitly any. You ya to explicitly tell me that this is any, or explicitly tell me that this is a string or whatever. So we should assign this as a string. We know that this is explicitly a string. The input argument is a string, and this is how you add types to your functions, so that whoever is calling your function cannot give you an erroneous input. If I try to call greet with 777, it says argument of type number is not assignable to that of type string. If I try to run this code or compile this code, it will not let me compile. It will be like, you have to fix the error here. This needs to be a string. That is what I made it here. And now if I try to compile it, it will work. You might ask, Akirat, what is the benefit here? You had to explicitly give it the type. If you are going to do this much mashakkat, if you're going to do this much hard work to put a type here, why can't you as the developer just, make sure you are passing in the right thing? How is this, something better? You still had to do so much hard work of putting a type here? The answer here is, as the code base becomes bigger, a lot of people will call this greet function, and then they might miss out ki this needs to expect 777 as an input, or a string as an input and not as a number. So for them, for future references, for everyone else to be able to understand what does this expect, is this a string, is this a number, without actually looking at the code, just by looking at the function signature, letting them see what inputs this function expects, is what TypeScript gives you, along with the type safety. Now if I was not in this file, if this function was defined in a different file I was using it, I could just hover over it and see ki bhai, this function expects a string as an input and returns a void as an output. We'll get to what this is, but this at least I was able to see ki acha, if I have to call greet, if this wasn't defined here, I could just call greet and hover over it and see ki acha, argument first name was not provided and first name is a string. So I can then just put in a string. That is why TypeScript becomes powerful as your project grows a lot. What did we have to learn in this part? How to provide types to arguments of a function. If you have multiple arguments, then each one of them will have a type. First name is a string, last name is a string, age is a number, so on and so forth. As your function grows, you can add various arguments. Each argument you have to specify the type. Okay, age needs to be something, last name needs to be something, so on and so forth. All right. We'll do a quick pause here. 10 more seconds before we proceed to the next one. Also do a quick poll. Is this part clear? Great. 97%. So let's proceed to the next section then. Sum function. Create a sum function that calculates the sum of two numbers. Function sum. A is a number, B is a number, and needs to return A plus B. This is how you would write a simple sum function. Let me call it. This is how I can create a simple sum function. This has something extra though. What that is, we will see. But first, write this code on your side. Going to give you guys 15 seconds in case you're writing it. All right. If you've written it, there is something extra to learn here, which is that this function also returns something. If I hover over this, it says the function signature is this, A number, B number, and this function returns a number. How it was able to figure that out is a different question. But how can you explicitly give, okay, what does this function return? The answer is this. Okay, when you're defining the function, these are the arguments, and this function returns this. In this case, in our case, a number. Given two numbers as an input, it also returns a number. This is how you can explicitly give it ki haan bhai, this function needs to return a number, so that whoever is writing the logic here, if they by mistake have some bug in their code base and they're returning a string, the compiler errors out. Okay, type string is not assignable to number. So this is how you can explicitly give, okay, this is what this function returns. Now if I hover over this, it still says colon number. These are the inputs. This is the output from this function. What is funny is, even if I did not give it this, it still gave me the same signature. Can you guess why? Because TypeScript was able to infer the type. This is what's called a new thing, type inference. TypeScript knows that bhai, A is an input, B is an input. If you a number, B is a number. If you add two numbers, that is also a number. And so it was automatically able to understand that bhai, this will return a number. You don't have to explicitly give it a number. Usually it's good practice to give it a number or a return type. This is going to return a number, but you don't have to, because TypeScript compiler knows input is number, out A is number, B is number. If you add two numbers, returns a number. You don't have to give a type here. It is able to infer it, but it is always good practice to explicitly say, okay, bhai, this returns a number, so that whoever is writing the logic here, if they by mistake return a string, you are able to catch that error at compile time. If I try to run this, it will break. It will be like, bhai, nahi, Type is incorrect. Again, it can only do type checking. Your logic could be incorrect here. TypeScript does not verify the logic. It cannot understand your code. It can understand types though. So if you return a wrong type, it will tell you that something is wrong in your code. You're returning a string when expected is number. So please fix it. Okay? That's what's called type inference. Okay, you don't have to explicitly give colon number here, although always a good idea to do it. That was the second thing, the sum function. Thing to learn was how to assign a return type to a function. And the third is return true or false based on if a user is 18 plus. So the input, create a function called isLegal, which returns either true or false based on the age that you've gotten, which is a number, if it's less than 18 or greater than 18. Can you quickly write it? I'm going to quickly write it. Function is legal. Input is age, which is a number, and it checks if age is greater than 18, then the person is legal to, let's say, vote, and then otherwise the function isn't legal, the person isn't legal. Notice here again, okay, boolean is inferred itself. I did not have to explicitly say that bhai, this returns a boolean, which is another type in TypeScript. The common ones that you'll really be dealing with are strings, numbers, and booleans. Boolean means either true or false, one of these two values, which is what is being returned here. So I don't again have to explicitly give it. Implicitly it understands, or it is able to infer the type, which is why if I try to call it with a whatever number and let's say assign it to something, let x equal to isLegal 18. If I hover over x, it already knows this is a boolean. I did not have to explicitly say, okay, this is a boolean. Again, always a good idea to explicitly put types here, but you don't have to. It is able to infer that bhai, this will be a boolean because I know isLegal returns a boolean. TypeScript compiler is smart that way. This is what's called type inference. That was the third thing to learn here. Fourth thing we have, but first three things what have we learned? How to give inputs to a function, how do you give a return value to a function, and type inference. How can the TypeScript compiler infer the return type? Lastly, create a function that takes another function as input and runs it after 1 second. This one is going to be difficult. So even if you don't understand this one, it is fine, but it's good to know, okay, how do you give type to a function? Let's see what that means. What is the problem statement? Create a function that takes another function as input and runs it after 1 second. Let's write this in plain old JavaScript. I've created a function called run after 1 second. It takes another function as input and runs the other function after 1 second. Cool. Do we understand this code to begin with? I can call this like this. This is what are called callbacks. You can pass a function as an argument to another function. Do we understand the logic? We'll get to what the types are here. But do we understand the logic of this? If we do, then I'll do a quick recap of this complete slide as well. Oh, great, we do. Perfect. So if we understand the logic, 90% to 10%, it's fine. As I said, it's fine if you don't understand this one. How do you give a function a type? What is the type of the function that the user can give as an input? Here you will learn something new. Okay, the type here is bracket open, bracket close, arrow, void. Okay, bhai. This is a function that expects no arguments. As you can see, the function that is being passed here has no arguments and it returns nothing. It returns void. If this returned an integer, then I would have said this is a function that returns a number. That is what I expect as input. But since I know this is not returning anything, it is a function that returns nothing. That is what I've given as the type here. All right. The thing to learn is how to give the type of a function. Until now, I had written function sum a number, b number, returns a number, return a plus b. This function had a type. You can see a number, b number, colon number. This is the type of this function. Similarly, if you want to pass a function as an argument, This is how you give the type of that function. Okay, this function expects nothing as an input, returns void as an output. This will come later on. If you don't understand it, it's fine. This is only useful when you have to explicitly pass a function to another function, which are what are called callbacks. You will see where this is needed later on. Good to know. If you don't understand, it's fine for now. What you should definitely understand is this part. Passing in arguments, which are numbers or integers or strings, return value for that specific thing, and this can be inferred implicitly. These three things you need to know very well. This part, okay, the function, what is the type of the input when the input is not a string or a number but a function, is this, and this is what the arguments of this function are, and this is what it returns. Void means it returns nothing, which is true here. This function returns nothing. So this is important to know, good to know. We will see where it is used. If you don't understand for now, it's fine. All right, cool. Quick recap, 4 things we have learned. Giving arguments to a function, returning values from a function, type inference. Even though I did not give a type here, it was able to figure out this is a Boolean. And lastly, how to create a function that takes another function as input. How do you give the type to the function that is being expected as an input? Cool. Take a breather. Let's move on to the next slide, which is the tsconfig file. Here we will look at some of these options that were present here. You don't have to know all of them. I don't think anyone knows all of them, maybe other than the people who created TypeScript. But there are some important ones. You should understand how does your compilation change as you flip a few of these arguments. Let's kick things off with the first one, which is called target. The target option in a tsconfig file specifies the ECMAScript target version to which the TypeScript compiler will compile the TypeScript code to. Oh my, too many things. So basically, if you remember, I told you guys, okay, there is a bigger organization called ECMAScript or ECMA, whatever they're called, which release every year, okay, bhai, this is how JavaScript should look like. For example, if you remember, okay, the functions can be written 2 ways. Yeah, so this, or they can be written like this, const a equal to arrow functions. This arrow function syntax was not part of JavaScript originally. This came into JavaScript much later when people realized, Kecha, this is another nice cool way to write functions. In some ECMAScript 2020, let's say, okay, when 2020 release of ECMAScript came out, okay, this is how JavaScript will be written from 2020 onwards. This is how this sort of functions began to be supported. Usse pehle, if you would write functions like these, your browser won't be able to understand. If your browser does not support ECMAScript 2020, let's say, it will not be able to understand these arrow functions. It will only be able to understand these normal functions. So every year some new specification comes out, ki, this is how modern JavaScript is written. And then all the browsers like Chrome or even the Node.js runtime needs to change their code to be able to understand and parse these new things that were added. When you're writing TypeScript code, you can write it in the most modern syntax. You can write it in ES 2020, 2021. But in your tsconfig, you can be like, bhai, the target, the final ECMAScript version in which this should be compiled down to, that you can specify as anything. Okay, it needs to be compiled down to 2020, 2019, 2018, ES5, ES4, whatever you feel is the place that your final browser supports. Let's say your application you're writing in TypeScript, but you are giving it to people who are running it in Internet Explorer. And Internet Explorer is, no one maintains Internet Explorer code base. Internet Explorer does not understand what arrow functions are. So Internet Explorer means the JavaScript file needs to have functions like this and not like this. Does that make sense? Internet Explorer, the old browser, some of you might not even know, does not support ES 2020. It only supports a very old version of ECMAScript. Basically, it does not understand this types of arrow functions. How can you tell the TypeScript compiler, okay, bhai, even though I'm writing TypeScript code like this, which is an arrow function, compile it down to simple JavaScript code that can run in Internet Explorer? The answer is this target in tsconfig. So if you open tsconfig and search for target, it says ES 2016, which is a relatively modern version of ECMAScript, which understands arrow functions. If you write an arrow function here and try to compile it down to ES 2016, in your final a.js file, you will still see an arrow function. But if you compile it down to ES5, which is a much older version of ECMAScript, you will see where greet equal to function name and then this syntax. No longer did this get converted into an arrow function. This got converted into a plain old simple function, just how things were done until ES5, or like a few years ago basically. So what does this let you specify? The target. Okay, what should be the final version of your JavaScript code? Why is this useful? Now you can write modern code in your TypeScript code base, but you can tell the compiler ke bhai, my code is going to run in Internet Explorer, so please compile it down to ES5, the old version. And then the compiler takes care of converting your arrow functions into plain old simple JavaScript functions. Cool. Hopefully that's straightforward. Let me do a poll, not straightforward, but at least easy to understand. Beautiful. Let's move on to the next one. These are important. Root dir and out dir. Root dir represents where should the TypeScript compiler look for your TypeScript files. The problem with our code right now is that my TS file is in the root folder. My JS file also comes here. So it will become much harder for me to see that this is my TypeScript file, I should make a change here. And this is my JavaScript file. This is auto-generated. I should not change code here. It's much harder to keep track of files if they're all shoved in the same folder, specifically TS and JS files. So what you can do is, what is the standard procedure is, okay, you create a source folder, src, and here you put a.ts. All your TypeScript code resides inside the source folder. Let me delete a.js. And all your final output resides inside other folder called dist. I repeat, your inputs, your TypeScript files should reside inside source. Your output should reside inside dist. Can you name this anything else? Yes. Another common name here is build. Okay, build or dist or distribution is where your JavaScript files are stored. Source is where your original TypeScript files are stored. And in tsconfig, you can tell it that bhai, the source directory or root directory, if I uncomment this option, the root directory is /src. Let me also revert this to ES 2016. Root directory is /source and out directory is /dist. The people who are on Replit might not be able to do this very well, but people who have it locally, if you change out dir to /dist and root dir to /source, and now if you run tsc-b, you will notice the a.js file is created in the dist folder and it is picked from the source folder. Now if I run node dist/a.js, it actually runs my code. Just a better way to structure your application, which is why anytime you see me initialize a new TypeScript project on a YouTube, live where I'm creating a TypeScript Node.js project, this is the first thing I do. After I initialize TypeScript, I change the root dir, I change the out dir so that the project is structured slightly well. The other benefit here is I can now introduce a git ignore file. Okay, what all files or folders should my git ignore? And here I can put dist. Okay, bhai. Here I can put dist. Okay, dist is a folder that's auto-generated. I should not push it to GitHub. Another important thing to know is you never push this final JavaScript file to GitHub. Your GitHub only contains your source code without even node modules, without this dist folder. You don't want to commit this to GitHub. Only your original TypeScript code, your package.json and your tsconfig get committed to GitHub. The final dist folder, whoever is developing this project, they run npm run build locally or they run tsc-b locally to actually create this. You never commit this on GitHub, which is why I've added this folder to my .gitignore. All right, cool. Root dir, out dir, no implicit any. This is also another sort of important one. If you remember, if I don't give it an option here, a type here, it says parameter has an any type implicitly. It implicitly has an any type. And that is because this error comes because your tsconfig has no implicit any as true. Okay, bhai, in the code base, there shouldn't be any implicit any. But if you want to make your code base slightly less strict, if you want to make sure कि चलो यार ठीक है, for now we're just transitioning from a JavaScript code base to a TypeScript code base. We don't want to give arguments explicitly to all functions. We will slowly and incrementally do it. So the TypeScript compiler, if you want it to just run for now, you can set this to false. And what will that do? That will be like, हाँ ठीक है. Even if you have not given me explicitly any, I will implicitly assume that the type is any. I will not complain. Versus if this was true, then the compiler will complain. Okay, bhai, give me a type. I don't know. When is this used? Usually this is used when you are moving from a JavaScript code base to a TypeScript code base, because over there are 1,000 functions. You don't have the time to give it types, in one go. So you flip this off for now. You incrementally add types to your code base as your application, gets some time and marinates into TypeScript. And eventually you flip this back to true. So that's how strictness is sort of controlled in TypeScript code bases. That is no implicit any. And lastly, remove comments. Again, there are thousands of these. You can read about them. There are like descriptions right next to it. I'm just giving you a few that give you an idea of what do these arguments actually let you do. Remove comments, as the name suggests, is if it is true, then if you have any comments here, they will not appear in your final JavaScript file. I have a hi there comment in my TypeScript file. Does not appear. Remove comments true. Would have expected it to not appear. Let's see. TSC-B dist error just. There you go. There is no comment here because I said remove comments true. But if I make it false, then recompile my project, I see the comment here. You don't really need the comments in your JavaScript file, right? No one's going to read through it. It's the final thing that just runs. People only read through the TypeScript file. Developers are spending their time there. So there's no point of bloating up the JavaScript file with comments, which is why you can set this to true. And that's what it's set by default as well, I think. Cool. These are some important tsconfig configurations. Are there more? There are thousands of these. Do you need to know everything? Probably not. But there are a few other here that as time goes by might be good for you to explore. Let me see if there's something important here that I know of. That declarations is an important one. We can get to it when we get to, deploying to NPM. This is probably another important one I want to share. Source map is another important one. But let's leave it for now. No need to understand any other configuration just yet. Cool. Quick recap. We understand TypeScript. What is TypeScript? What is a TypeScript compiler? We were able to write some basic programs, understand how to create functions in TypeScript and give them types. We understood type inference. And then lastly, we understood some basic tsconfig configurations that you can change. Now, let's understand two important concepts. Number one is interfaces. And number two that you'll see in the next slide is types. This is important. So mild attention pay here. Let's kick things off with interfaces. Take a breather, by the way. It's almost been an hour. Do you want a break? We can do a 8-minute break, a mess break for everyone, and then we can get into interfaces. Let's do a small mess break, guys. Let me look at chat until then. Polls and quizzes. How are we doing other than that? People who are in college, please, this is your time. Go to the mess, come back in some time. We're doing an 8-minute break. All right, people understand? Great. Again, feel free to skip through the slides. If you feel this is very easy, feel free to drop off as well. All of these slides are available. We're going to learn from these only. So if you understand everything here, feel free to drop off. All right. Let me open chat now if someone has any questions. Wow, too many of them. In TypeScript, we have to put semicolon at the end. No, you don't have to. Function calling another function is not working for me. Please show it again. Function calling another function. Okay. Basically, it was this function call after 1 second, set timeout CB after 1 second. There you go. quick recap of installing TSN configurations. Installing TypeScript into your project is as simple as tsc-p. This thing right here, that will create a tsconfig.json file, and the important ones here are out dir where you want to store your final JS file, source dir where you want to pick, root dir where you want to pick your source code from, and a bunch of others like these are like two arguments that you will change very often are these only. We will be providing types to a function whenever we are creating them. So why provide it to the passing function? We will be providing types to a function whenever we are creating it. So why to provide it to the passing function? Why to provide the passing function? The reason you have to provide to the passing function is because we have no implicit any turned as true. So if you look at this, it will say okay, this has implicitly an any type. That is the reason it's good for you to give a type here. If this feels too confusing, you can always do this any, and the error will go away. So this is fine as well. But the reason you have to give it a type is otherwise TypeScript will complain, okay, bhai, give me a type here. I don't know what this callback is like. We can use for type in JavaScript as well. Is there a difference? Big difference, very big difference, and a good question. Zod is for runtime time checks. This is almost 99% true. There is a way to do compile time checks using Zod as well. But the Zod we have used until now does type checking on runtime. Your code is actually running when Zod is verifying those arguments. This is during compile time. Big difference between Zod and TypeScript is Zod runs when your code is actually executing on a browser in Node.js. TypeScript compilation type checks happen during compile time when your TypeScript code is getting converted to JavaScript. That's the big difference between Zod and this. Everyone making changes in TS file, we have to delete the previous JS file and then compile it again. You don't have to delete it. It overrides. If I make some change here, for example, I did not delete it right now. If I recompile, if I close this and then recompile and then reopen it, you will see the new code has appeared here. In VS Code, sometimes you will see stale code here. So just close it and compile again. Install TS dev dependency. TSC, fine for me. Why? You install TypeScript as a dev dependency. So TSC -- init will not work. You will get TSC as a CLI if you install it globally, npmi-g TypeScript. Then you can get TSC as a CLI, command line interface, a command that you can put here. If you install it as a dev dependency, you cannot. Why is this function running? Let's see. I saw the same thing, the thing that you asked. I was like, I was also very surprised that this is running. Why is this function running? Even though it returns 5 here. Let's see. Function do something. Const do something to this thing. I'm basically intrigued. I would assume basically your question is this should fail, right? Because this is returning an int. Ideally this should be this. I thought the same thing when I was writing this code a few seconds ago. I will have to check. Let's see if I can give you an answer. Do something equal to number. Oh, okay. Yeah. Equal to this thing. Void. I will have to Google this if I'm being honest. This is a good question. I was pretty much thinking the same thing. Forget this. Look at this. This has a type that says function that returns void. Arguments, I do see it, but when it returns 5 here, why is this not complaining? I'll have to check. Good question. I thought the same thing, by the way. If you can figure it out, even better. How do you send logout alert to the user without the user sending a request from the old device? When he's logging from another device, you are not using WebSockets. Please explain when I was asking an interview question as well. Okay. If people, this is a slightly off topic. What will usually happen is you don't get a logout alert. The person's cookie gets expired. Their token gets expired. The one that they have in the browser gets expired. And hence, anytime they send a future request, the request gets failed and then the browser tells you, bro, you are logged out. You don't, it doesn't happen. It's not a persistent WebSocket connection. It's just that whenever you're sending an auth request, your next auth request will fail because your token will be expired on the backend. How can we convert a micro to mono repo. Why should we go for mono? What's a micro repo? Probably one multiple folders. There are 10 different reasons to have a mono repo. You can share code between them. The build times are faster. We will discuss this very soon when we reach turbo repo. And lastly, if user logs out and saves the token, so how to revoke it? On the backend, you can store their tokens in a database and then pass set revoked as true if they log in from another device. That's what happens here as well, right? On herkey.classes.co.in. If two people log in, one person automatically gets logged. As you can see, it said here an alert came that said you have 2 sessions, so I will log you out, and I got logged out. Same thing happens here. You basically don't have transitory tokens in that case. What do I mean by transitory? You don't have them not stored in the database. You actually store the tokens in the database and you revoke them. Oh, we're at time. No implicit any. Let me quickly explain, then we'll proceed. No implicit any basically means basically when you have some code in TypeScript, you have to give it a type explicitly. This is a number, this is a string. If you have no implicit any set as true, but if you have it set as false, then it will just assume case ka type is any, which is basically means it can be anything. So in TypeScript, if you want a very strict code base, you want people to explicitly say कि या तो ये any है, or this is a string, or this is a number, or if you want कि भाई for now it is fine, just assume if I have not given an argument, a type, it is any, then you can make this false, and then TypeScript compiler will be like, okay, the type of this is implicitly any. All right, cool. All right, let's get to interfaces. What are interfaces? How can you assign types to objects? For example, let's say there's a user object right here. Let's say I give you a user object like this. How will you create the type of this? It has 4 keys, not 1. First name, last name, email, and age. To assign type to the user object, you can use interfaces. It's basically a way to combine multiple things in a single object. If you have an object that looks like this, you can create what's called an interface. Okay, bhai, my user will have these 4 fields. And that's how you can get type checking in your code base. Let's look at the first assignment to understand this a little better. Create a function is legal that returns true or false. If a user is above 18, it takes user as an input. Let's try to write this code. There's a solution here, but would urge you to write it yourself. It says create a function called is legal, which returns, it takes a user as an input. Let me make this true. So this complains. If user.age is greater than 18, return true, else return false. What is the type of user? How am I calling this? I will call this like this. I will call it like this. What should I give as the type here? I can either write this. Okay, by user is an object which has first name, which is a string, last name, which is a string, and then age, which is a number. This works as well. There's nothing wrong in this. The only problem is if I have to use this type in a different place, I have to redefine it there. And if, let's say I ask you to create another function called greet, which just greets the person. Now you have defined this type in 2 places. This is code repetition. This is violating the dry rule. This is problematic for 1,000 reasons. You shouldn't have the same type defined in 2 different places, which is why you can create an interface. Okay, bhai, user looks something like this. Interface, user. This is what the user looks like. And then this user is also capital U-S-E-R. This user is also capital U-S-E-R. That's what is one of the things that an interface is. It lets you combine multiple fields into a single type. All right. Try to write this code, maybe call it, see if it works. Should mostly work. This is one of the benefits of using an interface. I'm going to give you guys 20 seconds to marinate this, right? Maybe 30 seconds. Write this code on your side. see how this is better than, the other one. That's what the solution over there was as well. Okay, you define the interface user and then use that as an argument. This is no longer number or string. This is capital USER, which is an interface which has multiple fields, first name, last name, email and age, which I've all defined here. Should be email here. It's fine for now. You get the idea. If email is expected as an input here, that needs to be passed here as well. One thing I should introduce at this point is optional arguments, which is if you feel email is something that the user can provide or not provide, then you can say कि भाई email is a string, but optionally user can pass it if they want, user cannot pass it if they want, depends on the user, whatever the user wants. So now I can pass the email if I want. If I don't want to pass the email, still I have no compilation errors. I see no red squigglies. Why? Because email is an optional argument. It's not important. I cannot write, whatever username here. If I type username, it will give me a red squiggly. But if I write email here, it's not giving me a red squiggly because email you can put. If you don't want, you cannot put as well, because I've put a question mark here. Question mark means this is optionally added. You can add it if you want. If you don't, that's fine as well. Cool. That's the first use case of an interface. Let's see the other thing. Create a React component. Okay, this one, you don't have to do it locally. You can do it as well. But basically shows you how to use interfaces in React, because TypeScript isn't just a Node.js specific thing. You can use TypeScript with React as well. Let me quickly show you how to do this. You don't have to do this on your side. But if you want to initialize an empty React project with TypeScript, again, you don't have to do this on your side. Just look at the screen, and maybe if you want to do it later on, feel free to initialize an empty React project like this. npm wait create @latest. Should probably be npx. npm create wait @latest. Give it whatever name you want. I'm going to call it TS React project. And now, after you select the framework, select TypeScript as the language. Don't select JavaScript. And now you will have an empty React project that you can open in Visual Studio Code. Let me quickly do it. But this React project is in TypeScript and not JavaScript. If you look at the files, it says app.tsx and not app.jsx. You see a lot of red squigglies because I haven't run npm install. So let me quickly run npm install. Again, you don't have to follow along with this. Just try to understand this. How can you do the same thing in TypeScript? Let me remove all the code here. Just showing you an application of TypeScript in React. How would you write real React code in TypeScript? Now that you have this code base, what is the assignment? The assignment says, create a React component that takes to-dos as an input and renders them. So if you create a React component that takes a to-do as an input, let's say, what is the arguments that it expects? It expects maybe, the title, the description, and then whether or not it is done. And based on these arguments, it renders the thing, right? H1, title, H2, description, so on and so forth. But here, as you can see, it's again saying has implicitly any type. You have defined an argument. You have not given it any type. So if you basically initialize a React project in TypeScript, whenever you're defining a component which takes arguments, again, you can write it like this. You can write it like props. Either one of them works. This syntax is also fine. The thing to note is that props needs to be given a type. And what will the type be here? I can be like to-do prop, which I can define as an interface. Okay, bhai. To-do prop, this function's props needs to have title, which is a string, description, which is a string, and done, which is a boolean. So this is how you would give types to a React component. You can write it like this, you can also write it the other way, where you can replace props with, an object which has title, description, and done. Both of the syntax is the same. Let me revert to the cleaner syntax, or easier to understand syntax, I guess. And now if I write to do here, if I type T, it shows me title is a property that I can give as an input. Go to gym. And whatever are the other properties, like description is a property that I can give, so on and so forth. So this is how you would add the same thing in React. Anytime you're defining a component, if the component expects any arguments, you have to give a type to that argument. Yeah, this props is of this type. That's what the question was as well. I think it was a little different when the question was. Like, let's look at the solution. It is slightly different from what I wrote here. This is for a to-do component. This is also for a to-do component, but the arguments are a little different. This expects a to-do. Here I expected title, description, done. Feel free to look at either. But the point is, whenever you're defining a component in React, the properties the arguments that it gets needs to be given a type. And this is the right way to give the type. What is the wrong way to give the type? You can just write any here. If you want to just get rid of squigglies for now, you can be like props any, give me anything, does not matter. You have to give it something though, because otherwise it will complain. Props implicitly has an any type. So this is the ugly solution to get rid of the squigglies for now. This is the more elegant solution. Props that I expect look something like this: title, description, and done. And then whoever is calling me or whoever is rendering me needs to give a title, a description, and then done equal to false, let's say. If I try to give something extra here, it will most probably complain. Subtitle. If I try to give something that it does not expect as an input, as you can see, it is giving me a red squiggly. So this is how you can add type checking to your React code base. Is that clear? You should try this out later on yourself, but most projects you will see, every project you will see that uses TypeScript with React, all the components will have, type checking like this. All right, cool. 90% good, not great, but here we will proceed. Happy to take questions at the end. Implementing interfaces. This is again good thing to know, not really used for the longest time, if at all, if I'm being honest. But let's go through it because it's like something to check box. We have done this. Implementing interfaces. Interfaces have another special property. When you define an interface like this, you can implement interfaces as a class. What does that mean? Let's look at it. Let's say you have a person interface. Okay, bhai, a person can have a name, have an age, and have a greet function, which, as you can see, a function which returns void. These three properties a person can have. Then you can define a class that implements person. Okay, by this person will have a name and a string. In the constructor, I'm going to take n and a as an input, name and age as an input, set the name and age for this specific object as these inputs, and then define a greet function which takes a phrase as an input, and then console.logs phrase space this dot name. Too many things happening. Let's break it down. Whenever you define an interface which has, let's say, not just types, primitive types, it also has functions in there. You can use this to implement classes. This is, if you remember object-oriented languages a little bit, if you've done Java a little bit, it's very common there. You implement interfaces in Java. Same thing here. Okay, you can implement this. Okay, bhai, whenever someone wants to create a person will have at least a name and an age, and every person needs to have a greet function associated. You can implement an employee class from it. And since you have an employee class that you can implement from it, you can also implement a manager class, a CEO class. Basically, all of these are people, right? All of these are persons. Employee is a person, manager is a person, CEO is a person. And all three of these have name, age, and greet. Maybe for the employee, the greeting says hello employee name, and for a manager it says hello sir employee name, so on and so forth. So this lets you basically add some object-oriented properties to JavaScript. Okay, you can define an interface and extend, or more specifically, implement that interface in a class. And this is almost exactly the same as interfaces in Java, right? Interfaces in Java are also the same, or abstract classes in Java you might have heard of, which is, this is the structure of what my class might finally look like. And this employee is implementing that structure, name, age, and greet. Here, what is this syntax? Let's write it down. Let's understand it. Let me open the Node.js code on my side. Let's copy over the interface. I have created an interface. This is simple. We have done 2-3 times now. It lets you aggregate properties. The employee class, you will notice a few things here which are different from how we have written classes until now. In JavaScript, when we wrote classes, we never gave this name, string, whatever. But in TypeScript, if you know there are things that you're associating to this, there are things that will be associated to the final object of an employee. What do I mean by final object? I mean this. Eventually you'll do this like const e equal to new employee. Name is Harkirat and age is, let's say, 22. This e object needs to have a name property and an age property associated. You have to define these properties above the constructor like this. These can also be public or private, but let's not go there. If you have anything bound to this, which basically means if you ever want to do, console.log e.name, if name is a property associated with employee, it needs to be written here. That's why I had to write it at the top. And these are initialized in the constructor. If you don't initialize this in the constructor, it again gives you an error. Okay, property age has no initializer and is not definitely assigned in the constructor, which is why you have to do this. Or if you know, you don't want to give age in the constructor, you can mark this as an optional property. Okay, bhai, everyone will have a name. Age is optional. They don't have to have an age. If they have it, it's fine. If not, that is fine as well. Let me revert. So this is another thing that interfaces let you do. Is it used very often? If I'm being honest, no. Rarely have I seen this. Why are we discussing it then? Because this is a popular difference between interfaces and types. The thing that we will discuss in the next slide. What is the difference? Okay, if you define an interface, you can actually implement a class from it. You can create a class that follows all three of these properties. Types don't let you do it. That is why we're discussing it, because it's a popular interview question. Okay, what is the difference between an interface and a type? They look very similar. And one of the differences is this. Okay, interfaces can be implemented as classes. Types cannot be. What are types? We will see in the next class. But hopefully you understand a little bit. Again, if you don't understand this too much, thankfully this is almost never used. But it's good to know. So let me do a quick poll and understand. How are we doing after this point? Do we understand interfaces? Should I repeat? Are we good to go? Oh, pretty bad. Okay. So let's take a breather here. Let me open Q&A. Any specific question? Can we define the type of function in interfaces? We have, right? This function will take a phrase as input and return void. Can we write the employee class standalone itself? What is the purpose of interface here? Great question. Someone asked, why can't we do this? Why did you have to do this, Harkirat? Implements person. The reason is, okay, now that I have this basic structure, I know that whoever is creating a class, let's say employee or manager, if they extend it, if they implement person, they will have a greet function. If they implement person and they don't have a greet function, it will give you an error. The benefit of having this is, okay, whoever is extending, or whoever is more specifically implementing person, on that e object, you can call greet. Greet will exist as a function because this implements person. So whoever is writing the code of manager will be forced to have these two types and this greet function. That is why you use the person interface. You could totally do this. This will also work, and you can define a manager class as well after this. But what is the whole goal of TypeScript? To make things strict, to find compile time errors, which you will find if you forget to put the greet function here and this actually implements the person interface. Versus if this does not implement the person interface, then you can write whatever you want. And this is erroneous. Every manager should have a greet function. Every manager should have a name, should have an age. That is why you can define a structure of every person, and then whoever is implementing it needs to implement greet, needs to implement name, so on and so forth. How to know when to use interface? versus type, you mean? You use if you're given a choice between interface and type. Well, let's get to types and discuss this question. Let me see if there is more things to discuss here. Was this the only thing that people were stuck with? Okay, why does this need to implement person? Why can we not do this? And hopefully that's cleared. Can we have an offline video on prototypes? Sure. TSC is slow but better. You pick and choose why one is better. I see no questions. Okay, someone said give me a TLDR. Let me give a TLDR. Does interface act as a class? No. Interfaces are not even present in the final JavaScript file. If I build this, an interface, a type, all the types that you see here, are JavaScript doesn't understand them. So they will not be present in the final JS file. They are only used for compile time checks. If this thing implements person and you don't give a greet, you have a compilation error. Your TypeScript code won't get converted to JavaScript. That is why you implement the person class and you get compile time errors or compile time checks. In the end, in your JavaScript file, you will not see any of this. Let's quickly compile this TypeScript file and see if that is true. Implements person. I've created a simple class that implements person. If I run tsc-b here, and if I open a.js, you will see it just has an employee class. Does not have an interface, does not have implements here, because it's not implements isn't something that JavaScript has. It is something that TypeScript added to add more type safety to the project, to let you enforce Java-like interfaces in JavaScript. Your JavaScript does not understand interfaces or implements. Hopefully that makes it a little more clearer. Okay, let's do a quick poll again. This is one of those difficult bits for today's class, which is like implementing interfaces. Okay, pretty good. 80, 84, 85%, 82%. Happy to come back to this. I'm assuming only the interfaces part is unclear and how you more specifically implement interfaces. We'll come to back to this at the end of the class. Let's try to finish a little bit more. Then happy to discuss this. Again, if you don't understand this specific title for now, it is fine because it will not be used for a long time, if at all. Cool. All right, let's proceed to types. Happy to come back to this later on. What are types? Very similar to interfaces. Types let you aggregate data together. So just how you saw interfaces, this is how you define a type. I think there is an error here. Where say copy this over to your code base. Yeah, there should be an equal to here. So type user. Oh, this is a JavaScript file. Never mind. Type user equal to this. One big difference when you're defining an interface and a user is you don't need to put an equal to here. You need to put an equal to in type. As you can see, these are very similar, almost exactly the same, right? A type and an interface are almost exactly the same. They're both letting you aggregate data. You can use either one of these when you define function is legal, user, user2 or user does not matter. Both of them are exactly the same. There are some subtle differences. Types you cannot use to implement classes. Only interfaces you can use to implement classes. That is one big difference. There's some other difference that we will see very soon, but high level, types and interfaces are very similar, almost the same for most use cases. How do you decide between what to choose? There are some cases in which only you can use type. Then you should use type. In most other cases, you should use interfaces. That's the standard practice I've seen of what to use when you're being given a choice between this and this. All right. What is type? Almost the same as interfaces, and let you aggregate data. But they let you do a few extra things. Number one, unions. Let's say you want to print the ID of a user, which can be a number of or a string. Forget everything. Take a breather. Let's say I ask you to create a new function without you looking at this solution that prints the ID of a user, which can be a number or a string. The ID of a user can be either a number or a string. This is something we haven't discussed until now. We have done this greet ID number. We have not done ID can be either number or strings. Let's see how you can do that. That is one important use case of types. Interfaces don't let you do this. Types let you do this. Greet1 does work. Greet1 with a string gives you an error. What is the problem statement? Which can be either a number or a string. Let's say you want to print the ID of a user, which can either be a number or a string. So this should also work. How can I make this type either a number or a string? You can either do this number or string. This syntax works as well. Or you can define a new type. Greet arguments equal to number or string. Either you can do this, or you can pull this out as a type and be like ID is greet arg, either number or string. That is the thing that types let you do. They let you define multiple types. This can either be a number or a string. Interfaces don't let you do that. You cannot be like interface greet arg equal to something. It will give you an error. Types let you define them as this can either be this, or let's say be a boolean, so on and so forth. And you can use this as an argument. That is one thing that types let you do. Is this clear? Straightforward, simple. Other than that, they're very similar to interfaces. They let you aggregate data, but they also let you do ORs like these. Straightforward, alrighty. Intersection. Let's say, what if you want to create a type that has every property of multiple types / interfaces? Let's say there is an employee type and there is a manager type, and then there is a team lead who has name also, start date also, and department also. It has all three of these properties. So there is an employee type, which can also be an interface. There is a manager type, which again can also be an interface. I can write this as well. Both of them are fine. Then there is a third type, which has name also, start date also, department also. How can you add? That has all three of these properties. You can be like manager, what is the syntax? And employee, type, and manager. And if I hover over this now, you will see it says employee and manager. Const t:\tech lead equal to name Harkirat, start date, new date, and then department, something random. There are no errors. Basically, every property here and here. If there is a repetition, then of course that it just has to be once in the final thing. This and this is the same thing. Name, department, and start date. That is the other thing that types let you do and interfaces don't. Other than that, as you can see, employee I can define as a type, interface manager I can define as a type, or an interface does not matter. But if I want to either do a or do an and, then you need to use a type. You cannot use interfaces. And if you ever want to create a class that implements a type, then you have to use an interface and you cannot use a type. That's the interview question of what is the difference between an interface and a type. Pretty popular interview question. I also asked this in the TA interview, believe it or not, and the expected answer was, interfaces you can extend in a class, and types let you do ors and ands, unions and intersections. If you know something can be one of two things, number or string, you will assign that as a type. If you know something needs to be an intersection of both of them, it needs to have name also, start date also, and department also, then you use a type and add a and here. That's what types let you do, and that's how they're different from interfaces. How are we doing? %. 85 is not great. What's the next slide? Arrays, enums, generics. We won't be able to do generics today. Let's do arrays, which is simpler than types and interfaces, and enums. Then rest I will cover in an offline video. But let's cover arrays, at the very least arrays today, and then we'll do questions. I'll pretty much stop after that. All right, cool. I think most questions are in interfaces and types. If there are any specific questions, let me look at chat really quickly. We can add two interfaces using extend, right? You can extend two interfaces or implement two interfaces. That's your question. All right. Happy to answer the questions in chat later on. I think someone wrote something which I think is right, and I think I was wrong at some point. But okay, let's proceed to arrays, which is how can you add array types in TypeScript. This will probably be the last slide for today. And then everything that's left afterwards, which is like 2-3 slides, I will cover in an offline video. Let's quickly cover this up and then I will take questions. If you want to access arrays in TypeScript, it is as simple as adding this annotation next to the type. For example, given an array of positive integers as input, return the maximum value in the array. If you have to write this function max value, which takes an array of numbers as an input, and you have to write the logic inside, let max value equal to 0. I can just copy this over. I think nothing too difficult when it comes to the logic of this question. The question is, if you have max value as a function that you call with, let's say, 3 values, 1, 2, 3, which are numbers, how do you define the type of that? Logic doesn't really matter. We have to understand the type. And the answer is you say number array. This array is a number array. Can you define it as an interface or a type? Yes, you can be like type number array equal to number array. This might be another thing that you cannot do with an interface. Yeah, you cannot do this with an interface, most probably. So yeah, this might be another one of those things that only a type can do and not an interface can. Number array equal to this. That's how you do arrays in TypeScript. And there's another question here, which is given a list of users, filter out the users that are legal, which also I'm assuming is straightforward. Given this user array, you have to create a function that filters users, which means it takes a user array as an input, which you can write like this. Okay, now users is a user array. The only thing to learn here is, you add this extra annotation at the end. Okay, this thing is an array of these things. Cool. Hopefully this is straightforward. Poll. Pretty good. I think let's call it here, guys. Iske baad it's enums are not too difficult, but let me cover it in an offline video. Generics are super important, probably something I would have anyways covered in an offline video. And then this part is pretty straightforward. If you want to read through it, you can. How to import and export modules in TypeScript, which is slightly different from how we've done it in JavaScript. All right. These are the 3 things that are left. I will try to post a video hopefully by tomorrow or day after, which covers all these 3. Let's go back to types and interfaces. Let me open chat and answer any questions you might have. And if you understand everything, feel free to drop off. I think the class ends here, and everything else I will cover in an offline video. It's like not too many things. Just generics is the only important thing after this. All right, too many questions. Let's see. Slides link is projects.100xtypes.com. Just select TypeScript. What if manager has the name number type and employee has a name type string? What will happen? What if manager has a name number type? Then you don't use interfaces. If they are not similar, if a user, let's say, only has name which is of type string, and interface manager has a name which is of type number, then there's no point of combining them. Then there's no point of creating a class user class implements user. This guy and whatever the manager class they will implement different things. There is the only place where this makes sense is where that there are things that are combined between both of them. For example, animal is a very popular use case here. Every animal has a name and has a age and has a, I don't know, bark, speak. How do they speak? Which is a function. Every animal has this. So now I can create like a mammal class which implements animal. And I can create what is the other type of animal? I don't know, fishy class which implements an animal, so on and so forth. because I know this and this all share these set of properties. But if you know that there is no sharing involved, then what you can do is something like this. Okay, if you know specifically in your case, okay, user has a age and a speak, or let's say just age, and then you can be like interface manager type manager extends user. How do you extend interface manager name number and employee and name string? So that way manager will have both age and number, employee will have both age and name and age and name, but this guy's name will be number, this guy's name will be string. So if you want to share some things, you can share it this way and use extends. But yeah, hopefully that answers your question. Okay, please review my project. Only if TypeScript had type, if only TypeScript had the type first and variable name after that, wouldn't it have been better? Oh, that just depends on the TypeScript maintainers. They wrote it like this. They did not write, int x equal to 1. They wrote it like this. So yeah, it just depends on them. By the way, in Java, the interface doesn't specify variables. By the way, in Java, okay, it might be possible. Totally been a while. Abstract class is probably a better example of how interfaces implements here, probably. Please explain which one is better for us, interface or types. If you don't want to use something like, do something like this, type a equal to user or manager. If there is something that can be done via interfaces, do it via interfaces. But if you know this cannot be done via interfaces, you cannot be like interface a equal to either user or manager. Or can you? You can probably do this. Yeah, you cannot do this, right? Yeah, you cannot do this. So for these use cases that cannot be done via interfaces, use types. I mean, I'm sure there's a better practice. This is how I have seen things being done. This is how I do it when I'm writing code. Might not mean that this is the right, standard practice. There might be a reason for you to use type here. But from my guess, you use interfaces until you reach a point where you cannot use interfaces. For example, if you have to do a or and and, then you use a type. Please give example of callback where it is called function accepts 2 arguments and returns a string. Function cb1, cb2, string. This is void number string and returns a number, let's say. And let's say this returns 1. And then you call cb1 and you call cb2 with a number 2. The number and return string rate. Oh, sorry. str. There you go. This is an example of, let's call it do something. A function that takes, this was your question, right? Sorry. Please give us an example of a callback where the called function accepts 2 arguments. Oh, called function accepts 2 arguments. My bad. So cb2 string and whatever num, which is a number, and then here you call cb2 with this thing and a number. There you go. You probably don't even need cb1. Was this what you were expecting? The called function accepts 2 arguments and returns a string. Accepts 2 arguments and returns a string. Const x equal to this, and if I hover over x, you will see the type of x is string, because I said the called function returns a string. Might be a little confusing if I'm being honest, but this is the exact answer to your question. How are we able to intersect an interface and a type together? You said only type. No, you can interface. Interface manager name hierarchy string type tech lead time date, and then type both equal to manager and tech lead. No errors. You can do an and or an or on both interfaces and types. It will not give you an error. You cannot use interface here, is what I meant. You can never be like interface both equal to manager and tech lead. If you want to do a union or an intersection, it needs to be a type. How are we able to intersect? Okay, answer that. What if the manager has the answer that? Are you going to make the Paytm Zarda full clone or not? Please make the full clone front end and back end for the same. Please should be fully clone and not some specific part clone. Sure. And can you explain interface again? Sure. So interface and type are very similar. High level, the thing that you really need to know is they let you aggregate data. There are nuances, there are differences. There are things that a type can do and an interface cannot. There are things that interface can do and type cannot. But what is the first thing that both of them let you do? They let you aggregate data together. If you know a manager has a name and an age, and there is a function that takes manager as an input, this is a better way to write the function rather than not defining the interface and doing this. You can still do this. M is of type object, which has name, string, age, number, but this is the better way to do it. You define an interface which has both the things and you use them here. That's what an interface is. Type is very similar, only the syntax is slightly different. That is the first thing that both of them let you do, is aggregate data together. Now there are things that types let you do that interfaces don't. There are things that interfaces let you do and types don't. Specifically, interfaces can be implemented by classes and types let you do unions and intersections. This is the difference between them. For most use cases, you can use either. What do I use? I use an interface until I have to do a union or an intersection when I use a type. If a callback function has arguments, then how to give a type on it? What is constructor? I think I answered that a few minutes ago in a different question, but let me give it to you again. There you go. The callback function has two arguments, a string and a number, and this returns a string. And whenever I'm calling the callback function here, I'm giving it the two arguments, string and a number. If I don't give it an argument, TypeScript will begin to complain. This expected two arguments, the callback function of yours expects two arguments, so you have to give them here. What is a constructor? You should go back to the class where we've done, you should go back to the class where we've discussed class. Go back to the lesson where we've discussed classes. I think it is in week 2 or week 3. Yeah, there's a whole class on classes. There you go. Oh no. Which one is it though? Loops, functions, one of these two, most probably this. Basic JS APIs, beginners. This one contains what are classes, which contains what are constructors. I think I moved a little too fast in that class, so if you don't understand it, let me know. We can create another one. How can I build a JavaScript project without watching tutorials? I'm unable to recognize all the concepts and logics. Practice. Start with a smaller project and then make it bigger. But let me first answer more questions related to the class. Can function type be inferred if we have already defined a function with its own types? If you have defined a function where you have explicitly said it returns a string, then no, this will not be inferred. If I return a number here, TypeScript compiler will complain. It will not infer automatically it returns a number. But if I don't give it a type, then it will infer, this returns a number, I can tell. But if you explicitly give it a type, then there is no type inference that is happening. You have explicitly given it a type, so you either return that type or the TypeScript compiler gives you an error. Is TypeScript a dev dependency or a normal dependency that goes into production? Great question. TypeScript never goes into production. Ideally, TypeScript should only be part of your build pipeline. TypeScript is used to convert to JavaScript code. Your final production, your final thing that reaches your Node.js servers, AWS servers, React project should ideally just be the JavaScript files. You don't need the TypeScript files to ever reach the final place where your code is hosted, because TypeScript never runs. TypeScript should be part of your build pipelines. You take the TypeScript code, convert it into JavaScript. Once JavaScript has been spit out of the TypeScript code, you take that JavaScript bundle and you put it on your server. You never really need to put the TypeScript code on your final, repository wherever you're hosting server like AWS server. How do we exactly know every type of a certain component in JavaScript? Example, type of an error object in a try catch block. In a try catch block, throw new error. Yeah, this is not a pretty good question. How do you explicitly know the type of E? What is the type of E? It is unknown. Specifically for this This is what I do very often. I think you can define an error type here, but you cannot explicitly know the type of everything. I do get what you're saying here. How do we know the every type of a certain component in JavaScript? For example, specifically what like try catch is a very weird use case that you ask for, because every time I've seen this, I've myself boggled my head. What should be the type here? Should it be error? Should it be any? And I usually resort to any here. But this is a good question. Specifically for this, I don't know. But I think other than that, I think you already know. This is a smart question, so I'm sure you understand everything else. How do you know the type of a certain component in JavaScript? Basically means how do I know the type of this thing? And the answer there is by default it is unknown. Unknown is another common type similar to any. Basically means the type of this is unknown. And how do I know the exact type specifically here? I have no idea. Probably after Googling a bit, I can give you an answer. But in most other cases, I mean, I think you know the answer to that. Everything else, I'm not going to explain anything else. More things. It's a smart question, so you know everything else. This part, basically, I don't know the answer. Happy to Google after the class. Or someone posted a blog post, which is a good one to look at if you're trying to decide which to use, TypeScript versus interfaces. I'm sure there's a good reasoning here. Interfaces cannot express unions, conditional types. Type aliases can express any type. Interfaces can extend, types cannot. Oh, this is another thing. Interfaces can use extend, seems like types cannot use extend. Not implement, extend. What was extend? The thing that I showed a few seconds ago. Yeah, basically a good thing to read. Interfaces with the same name, the same scope, merge declaration lead to unexpected bugs. Type aliasing with an implicit index signature of this thing becomes, which comes out full explanation. Yeah, read through. This is a good blog post. Happy to summarize this later. This one, interfaces, we discussed interfaces cannot have unions and intersections. Types can. Interfaces can extend, types cannot. This is an important thing that I missed. Okay, you can, if you have an interface manager who has a name and then interface user who has an age, you can have interface big person, which extends a user, which means it will have all the properties of user plus something extra. And I think you can extend multiple things as well. Extends both user and manager. So it will already have this and this. You cannot do the same thing in types. That's probably another difference. All right, cool. Are you going to make, answer that. How can you convert a microservice into a monorepo? And if so the short answer here is go here, not Mongo, Turbo repo. And this has pretty much the exact solution to your problem, which is if you have an existing project, which is not a monorepo, how to add it to an existing project. This is just one monorepo framework you can use. There are many, but specifically for Turbo repo, which is basically a monorepo framework, how do you add it to an existing project? That's your question, right? If you have a existing project, which is not a monorepo and you want to convert it into a monorepo, how do you do it? This is your answer. Every repository has different ways to do it. Generally, it's a very hard thing to move a project that wasn't a monorepo into a monorepo. You will not use the standard practices for a while. Slowly, you'll move your code base there. Generally, it's a good idea to originally have a monorepo. It will be a pain to move a non-monorepo to, a monorepo. All right, what's the other question? Then how can we run all the services in a single repo? Like we have created an instance where we have to host them in different ports. Yeah, both of your questions seems like whoever asked you this question seems like this was an interview question. The answer is just read through what a monorepo is and how you can host and even have multiple code bases, a front-end code base, a back-end code base, another front-end code base in a single project. Monorepos basically let you do the same thing and you run projects on different ports basically in that case. Cool. How did you make the daily code website? It's just Next.js and Firebase. Can you open gitignore? What is the greet function? Can you open gitignore? It just has dist because I don't want to commit this. What is the other thing? What is a greet function? Basically a function that takes a name as an input and greets the person. Console.log. Hi there plus name. That's all. While rendering React component after defining types using interfaces, okay, how to pass the props in this way? To do props is different from React.fc to do props. Yeah, good question. The one important thing, good question. Probably easier to discuss after we've discussed generics because this uses a generic, but high level, whenever you have a React project or a React component, it will always have children as an argument, or at least should always have children as an argument, because whenever you're defining a component, you can pass something inside. Hi there. So what React.fc to do props lets you do is, this is what's called a generic. It will have some default values already there, and on top of them, you can add to do props. I'm assuming that's what it does. And that's why people sort of use this and not directly use to do props. But it'll be a little more clearer after we've discussed generics. That's my guess right now. Okay, React.fc, if you pass this as a template or an argument here, it gives you the standard properties that a React component expects, which is children is the most important one here. Okay, it'll always be present in a React component. You can always access, props.children, which can be undefined. It isn't necessary that someone passes you this, but can be defined as well. And so that you don't have to explicitly be like, children equal to something React node, and then the other thing, you do this, you use React.fc is what I'm assuming. Could I be wrong? I could be wrong. Happy to Google this. What is React.fc? Functional component. Oh, it's FC starts with functional component. That makes sense. Let me not waste everyone's time here. But yeah, there you go. I think that's title when this thing is equal to. Yeah, as you can see, like title is defined here as the argument, but you can get not just title but children here. And these children probably come from this class, is what I'm guessing. Happy to look into it more later on, but that would be my guess. How are we able to intersect an interface and a type together? You said only types can intersect. No. Types and interfaces can be intersected. So you can have a type X equal to A or B, where A is an interface and B is an interface. I said the thing on the left, X can only be an interface. A type. This cannot be an interface. You cannot do this. But you can do a type X equal to, this can be an interface, this can be an interface. The things on the right can be an interfaces. Thing on the left, this thing cannot be an interface. Is an interface like schema, where we create in the database? Sort of. The thing is, schema is something that's present on runtime. It will actually block your data from going into MongoDB if you don't follow the schema. Versus these types are compilation things. When you run tsc-b is when these come into the picture. They're not really used during runtime, versus the schemas that we define here are actually used during runtime. So they're actually pretty significantly different. I noticed one thing. I had declared the same function in two TypeScript files and it was showing an error. Can we not call the function with the same name in same directory? I declared the same function in two TypeScript files. I was showing an error. Probably shouldn't. Function A. Console.log hi. And if I define a file right next to this, you might be running into some specific use case, but this should not give you an error. You can define the same function. Oh, it is giving me an error. You're not wrong. Duplicate function implementation. ये तो मैंने भी पहली बार देखा है. Let's see. What is this? This is an error. Seems like this is an error. The problem is that you have this thing after two lines. It actually defines an empty implementation of. Oh, seems like if you have an empty implementation, this happens. Let's see. No, this isn't empty. Hello. Great question. One that you deserve a bounty for, because I have no idea what this is. This is the first time I'm looking at this. Let me write this down. Let me just take a photo of the issue. Happy to discuss, like put this in the offline video. We'll put this, in fact, I will put this in the offline video. This is a good one. All right, let's see. After, I'm a little curious to look at this. When you overload or you only have one implementation, multiple signatures. I mean, it seems like it, it's related to overloading in TypeScript, but okay, I'll look at it later. So that, what if manager has the same number type as the employee? Okay, answer that. This looks incorrect. This was incorrect in the slides as well. So this is not your fault. It needs to be type user equal to this and not this. are you going to answer that? If only TypeScript had the type first and okay, answer that. If we haven't understand this completely, is it okay to leave JS behind and have a strong grasp on TypeScript? Probably not. I mean, you should understand JavaScript first. They're very similar, right? There's something extra on top of TypeScript. Sorry, JavaScript. What if I think I answered this logout question. What if manager answered that? Okay, let me do one more round. A few repeated questions here. Go for it. Chat is open, guys. All right. TS compiler looks at multiple files, duplicates in any file inside the folder containing TS config shouldn't have the same name. Why though? I mean, it makes sense. TS compiler looks at multiple files, duplicates in any file inside the folder should containing TS config shouldn't have the same name. Okay, makes sense. You said same folder. Does that mean if I create a new folder and put this here, it will stop complaining? Seems like it does. So you cannot define the same function name in multiple files in the same directory in TypeScript. The TS compiler looks at multiple files, duplicates in any file inside the folder containing TS config shouldn't have the same name. Sounds good. Surprising, I never came across this before. I have emailed Hedex devs a week ago regarding course upgradation. I'll ping Rookie, but don't worry about it. We have a month before course upgrades becomes a problem, so shouldn't be a problem. But let me still mail Rookie. Please check mails. All right. Should I spend time mastering React.js or wait for Next.js video? You should spend time doing React. Next isn't anything new. I mean, it is something new, but until we reach there, if you don't do React well, Next will be a problem. So do spend time doing React. Next isn't different. It's not like Angular. It's something on top of React. So you need to have a good grasp on React before you can move to Next. Compiler not giving error when using this thing in interfaces. When using OR in interfaces. How are you using OR? Interface X. How are you using OR in an interface? Can you post the exact thing here? Samir Chand. As I said, the thing on the right can still be an interface. You can have type X equal to interface 1 or interface 2. This is fine. Thing on the right can be interfaces. Thing on the left cannot be an interface. Please show the syllabus we have covered. What are the things we had to cover in 0 to 1? Let's see. Which one has the syllabus? This one right here. We have covered Foundation, asynchronous, Node.js we have covered. NoSQL we have covered. Postgres deep dive we'll do next week. TypeScript we'll sort of cover. Basically almost done with this next week because next week we'll do Postgres. Right side we have done a bunch of this custom hooks. Basically Next.js is left. Docker is left here. And next auth is also because Next.js and next auth. And basically 1, 2, 3 left here. 1, 2, and 3. And then here ORMs are left. Mono repos are left. Serverless block backends, this thing. A lot of this I'll just move to 1 to 100. As in like we can do later on. This and this are pretty similar. Can be covered in a week. This we haven't covered or like sort of have. JWT we have used. Scaling Node.js is a random class. Yeah, pretty close. I think if we really want we can cover this in a month, we'll probably extend this to at least a month and a half. Like we'll probably finish 0 to 1 mid of next month or mid of March basically. How do interfaces differ from database models and schema definitions? Great question. They are significantly different. Your JavaScript file does not contain the thing that is finally created. Doesn't have any concept of, this will never contain an interface. Whenever you compile your code, this will never have a type, never have an interface, never have any TypeScript related things. This will have your schema related code though. So your schema related code actually runs. These types that you've defined are only used by the TypeScript compiler when it is converting to JavaScript. Never really used after it. So the big difference is that is actually present in your JavaScript code actually runs. This never runs, just using the compiler. To run a command for Mac, create a.sh this thing, permissions this thing. Okay. What if I have to use both interfaces and types to explicitly declare the type? Which should I use? Union and it needs to extend a class. Where is your project built if it is deployed on a server? Oh, So where your project built is a good question. It is built in usually GitHub CI/CD pipelines. We'll probably get to that in 1-200 or 0 to 1, I don't know, wherever it's present. So it's basically built on some servers, but not your final server usually. Your final server, which has your JavaScript code, just has your JavaScript code. That's the only thing that reaches there. The conversion from TypeScript to JavaScript happens in some CI/CD pipeline wherever you're running it. Usually is in some GitHub servers, which are usually AWS only. What if I have to use both interfaces and type for an explicit declare? To explicitly declare the type, which will use union, and it needs to also extend a class. Firstly, types never extend a class. You cannot have a class X and you can use a type Y. Oh, okay, I get your question. You're like, what if I have to both extend and do an or? That's your question, right? So you'll first define the first interface, then you'll define the second interface, then you'll define the third interface which extends both A, B, and then you will define the type D, which is C and A and whatever, E, so on and so forth. So you first define the interface which extends and then define the type which actually does the and. You cannot, be like in a single line, you won't be able to do this. Basically, you have to do this in multiple lines of code. Is it possible to build a CI/CD pipeline where you could configure the TS config to transpile the TS code in TS16 for one deployment and TS10 for the 20? Yeah, you can do that. Yeah. What do you have to do? In CI/CD pipeline, you just have to replace the TS config, final version to 2019, 2018, 2017, and then build it twice and then push them to different. Yeah, you can have different CI/CD pipelines. You can have multiple TS configs in a different folder and copy over the right one to the root folder and then build it for one CI/CD pipeline, for other CI/CD pipeline. You can do that pretty easily. Moving forward, can you please work in TypeScript only in front end and back end? So it's a good habit for us to do assignments in TS only. Yes, you don't have to say that. I will definitely do that. We have done with JavaScript. Yes, we have only done TypeScript. Does TS convert TSX to JSX? Good question. I don't know if it converts TSX to JSX or if it converts, does the final conversion of JSX to JavaScript, which is what React does. I don't know if it is a TSX to JSX and JSX to JavaScript conversion or if it's a direct TSX to JS conversion. So yeah, basically don't know the answer to that exact question. Does it happen? If that's your question, does TSX first get converted to JSX, which then gets converted to JavaScript, or does TSX directly get converted to JavaScript? If I had to guess, I think TSX would directly get converted to JavaScript. Could be wrong. Is interface same as defining the types in a class? No. Class is a runtime concept. You will find classes here. Interface is a TypeScript concept. You will find types here, never find them here. How a this keyword in a class inherits the type of the instance of the class? How a this keyword in a class inherits the type of the instance of the class? And when context of this changes, does it change the type of this as well? I don't understand your question very well, but let me try my best here. If there is a class which has a constructor and has a method, let's say sum. What's your question? How does this variable, this keyword in a class, inherit the type of the instance of the class? Inherit the type of the instance of the class. No idea what this means. Let me copy this and paste it for later. I'm unsure if I understand your question exactly. So let me keep this in a stash and maybe just post it on Discord and tag me and happy to look at it. Maybe elaborate a bit when you ask the question over there. Can you explain git ignore part while passing objects as argument? Can we have any type? You can have any type. Usually the practice is to not. You should not have any types through your code base at all. You should always give them some explicit types. And the git ignore part was, if I initialize a Git repository here, I do a git init and I do a git add dot. If I don't have dist here, if I do a git add dot, you will see dist/a.js got added. If I commit and push this to GitHub, a.js will get pushed to GitHub. I don't want that. The JavaScript files are auto-generated or generated by the TypeScript compiler. You don't want them committed on GitHub, which is why if you ever go to any GitHub project, you will not see node modules there. You will not see any JavaScript files there. So you need to make sure this is not committed. So you can do two things for that. You can either be like, when I'm adding, I will make sure I don't add the dist folder. I will do a git add source, git add tsconfig, git add package.json. I will not add dist, so I will leave it, and I will always manually check I'm not pushing in dist, or you can just put dist here in .git ignore, and when you do that, now even if I do git add dot, git will ignore dist. If I do git status, you will see. I don't know why that happened. Let's see. Yeah, if I do git status, I don't see dist here. Why? Because it's part of git ignore. Git is ignoring it. Even if I do a git add dot, Git said I'm not going to look at this and push it to GitHub or commit this. That's why you put dist here. Usually look at any big project. What can we look at? cal.com. You look at the .git ignore. You will see like a bunch of things here. Node modules, dist. You will see build. You see like 10 different things that are present here. But as you can see, dist is present here because even they don't want the dist to be pushed to GitHub. Getting this error while executing tsc-b category error security. Ye kya hai bhai? This was something very weird. There's something in your local installation that you might have to fix. Oh, Windows. Basically I cannot help you out right now here. Neither do I think a TA can help you out here. You will have to choose some glass. This is some Windows error that you're seeing while compiling TypeScript. If I was you, I would uninstall Node and then reinstall Node and then reinstall TypeScript. Harkira, do you know, number one, do you know what keystrokes are displayed on Zoom window in the left corner? Hope you don't have enter a password or something. I have, but I changed the password. Number two, my opinion on interfaces versus types. Thinking from OOPS perspective, I think interface should be used when defining attributes of an object. The concept of type doesn't naturally fit trying to define an encapsulation whose purpose is to specify what common data attributes can be there for objects implementing an interface. That makes a lot of sense. Yeah, I would agree. Is interface the same as defining a type in a class? No, as I said, it's pretty different. Okay, answer this question. Can we watch TypeScript video you have to put on YouTube after this lecture? Will all this cover everything? I think I just posted last cohort's TypeScript videos. You can just look at them. They're the same. They're just a bigger version of what was put on YouTube. How to have a monorepo in a Web3 project which has a smart contract folder in it? It doesn't make too much sense for you to have, to have a monorepo which has solidity. Monorepos make sense, or when you can share code between multiple files, which only happens if you have JavaScript and TypeScript. You don't need a monorepo if you have a solidity contract folder. Just put a folder there. You don't need to have the concept of a monorepo. Monorepo lets you do 10 different things that are only possible if your whole project is in TypeScript. Do we also build React projects? How this build is different from npm run build? Oh, good question. What is npm run build? It's nothing. It's just if you go to package.json, there is a script section where I can add build, which I can say, okay, when the user runs npm run build, please run tsc-b. So npm run build isn't anything special. It's just package.json mein whatever is present in scripts as build is what runs. So when I run npm run build, that is what actually runs. So if you're in a project and you're running npm run build, you can always open package.json and see what that actually runs under the hood. Can interface extend another interface in TypeScript? Yes, it can. Difference between interfaces and abstract classes in TypeScript. As I said, abstract classes. I feel like I've used them, but I'm not sure. Does TypeScript have abstract classes? It does have abstract classes. Let's see. Okay. Abstract class and then employee class. Let's see. If I have an abstract class and an employee class, uske baad and let's say I run npm run build, and if I look at dist/a.js, oh, it still has only a class. Oh no, never mind. Let me open this again. Abstract classes thing. Yeah, very similar. What is the difference between an interface? I guess one thing I can see is, when you're defining the abstract class, you can have a base constructor that whoever is extending will be able to use. You can also have, oh well, there you go, right? You can have functions in the abstract class. Some methods are abstract. Some methods are already implemented. You cannot do that in an interface. An interface, you cannot have any runtime code, any function implementation, versus in an abstract class, you can have implementation. That's probably the difference. What is a tuple type? Oh, it's basically this return, if function X returns number comma number. Does JavaScript have tuples? Tuple type script. It could. I'm not saying it couldn't. Oh, it's just an array. Seems like it's just an array. Like it's nothing special. I would have expected. Yeah. Tuple is a more Python concept, I think. But here, if you want to return more than one things, you can just return them in an array, I guess. I don't think there's. That's what I would have guessed. I don't think there's a tuple concept of a tuple in TypeScript. Oh, it is. Hold on. Could be wrong. Yeah, it's just an array which has two values, which is what you call a tuple. Can you make all properties of an interface optional? Yeah, you can. You can be like interface name, user name is optional. Oh, sorry. Yeah, it works. No errors. Can you use types like interfaces, extend types and do intersections, right? You can use types to do intersections. You can use types to do intersections. You can use interfaces to extend. Both are different. You can do this thing. Yeah. You cannot use types for this. You cannot use interfaces for this. We can use, okay, answer that. How do interfaces differ from a database? I answered that. They're like very different. One happens on runtime. One is present in your JavaScript code. These interfaces are never present in your JavaScript code. Yeah, oh. Sorry. TypeScript compiler looks okay. Answered that. How does this work? Okay, let's see. Baapre. You get back the response from the backend. You set that. Let's just focus on the sign up function, I guess, which is or sign in function. You send data to the backend, you get back the token, and you set that in the local storage. Then you navigate the user to dashboard. This is from the Paytm project, by the way, for people who don't understand where this code comes from. And then you navigate the user to the dashboard. And now, since your local storage has that token, in every subsequent request, like I want to transfer money or I want to get the list of users from the backend, you send this token along. And hence, authentication works in your application. Covered this in detail in the front-end video of Paytm 8.4. Is it possible to build a CI/CD pipeline? Okay, answered that. Is interface the same? I answered that. How do interfaces differ from? Answered that. Alrighty. Cool, hey guys. Happy to open chat one more time, but assuming we good to go. Any more questions? Ignoring all the questions. Okay, someone is clarifying something about duplicate function implementation. When you write a function with the same name in code structure as a function already defined in a different TypeScript file within your project, even if they are separate files, TypeScript will raise a red error saying duplicate function implementation. Yes. Why does it happen? Ambient modules. When you don't use explicit imports and exports in TypeScript, they become ambient modules. That makes so much sense. I don't know what ambient modules are, but I get from first principles what this means. All the contents, including functions, are treated as a part of a single global namespace, defining functions with exactly same significant error. Okay, let's see. So if I define a function, call it sum here, and then I define the same thing, move this outside here, it gives me an error. But if I export this, then it's fine. If you do not export specific functions, if you define a function in two files and neither one of these are exported, then they both reach the same place eventually, which are called ambient modules in TypeScript, and then there will be a conflict. Okay, bhai, yahan pe bhi sum defined hai, yahan pe bhi sum defined hai. They cannot have the same name. Great point. If generics and topics are yet to be covered after today's class, which is present in the video, present offline video, then why upload again? Is everything that's left to covered? Probably not. I mean, generics are present in the cohort 1 video, but let's see if everything. I mean, import export modules is definitely. I mean, I can just cover it again, right? Yeah, I don't know if enums are also present in that video. Happy not to. People get angry. Oh, you're posting cohort 1 videos. So I don't mind. I'll not happy to not upload. Is there, if a generic top, okay, answer that. Is there any multiple set timeout calls within a 10-second delay? Will they run simultaneously in the callback? If there are multiple set timeout calls with a 10-second delay, will they run simultaneously in the callback? The total time it takes nearly 10 seconds, not 20 seconds. If there are, yeah, I mean, this seems like a slightly more basic question that, should know by now, which is if you have a set timeout which runs after 10 seconds, and then another one that runs after 10 seconds. Both of them will almost run after 10 seconds. This will run after, let's say, 10.01 seconds. This will run after 10.001 seconds. Of course, they won't run at the same time. This is a very expensive operation. If you put a while loop inside, that goes from, or a for loop that goes from 1 to 10 million, then this will probably run at the 11th second. If this operation itself takes 1 second, then until the thread becomes free, control won't reach here, but it will not be 20 seconds. It will not be like, first this line ran, and then, after 10 seconds, this clock started. Clocks start together. This function will start executing, or one of these will start executing first, whichever went to the, came back to the callback stack first. And then once that stops executing, the other one will execute, right? You should go back to the initial videos if you don't understand this part. If there are, okay, so that, you mentioned that TypeScript runs in a JavaScript environment, but also undergoes conversion to JavaScript during runtime. TypeScript runs in a JavaScript environment. We cannot say that. It does not run in a JavaScript environment. TypeScript is a independent thing that gets compiled down to JavaScript. That's all that a TypeScript needs to do. Does not need to run anywhere. But it also undergoes conversion to JavaScript during runtime. Does not get converted into JavaScript during runtime. When I'm running tsc-b, this is not runtime. This is compile time. This is it getting compiled down to JavaScript. This is not runtime. Runtime is when I run node disk/a.js. This is runtime. TypeScript has nothing to do with runtime. In JavaScript, which is loosely typed, could this not potentially contradict type restrictions imposed by TypeScript on variables and function names and at runtime? So TypeScript can do nothing at runtime. All TypeScript code gets wiped off here. TypeScript can tell me this. If I go to chat.openai.com and I put a prompt there, give me some code. It will give me some JavaScript code. If I finally run the code here, can ChatGPT do anything from preventing me from running this code? Can ChatGPT change that code? No. Only once that JavaScript code gets generated, TypeScript can not do anything after that. TypeScript only purpose is, given this TypeScript file, convert into JavaScript file. That's all. And if there is some type error there, don't convert to JavaScript file, give an error. That's all. It has nothing to do with runtime. When you run the final code, TypeScript cannot do any type checks here, cannot prevent code from running, cannot put any, does not even have an if else check or anything, right? TypeScript, you just define types and put them as arguments. You do not have an if check, if type is this, then do this. So you cannot do anything in runtime. For instance, in TypeScript, you might declare a variable like this. However, in JavaScript, it simplifies to this. Considering the loosely typed nature of JavaScript, is there not a risk during runtime? Someone might inadvertently pass the value to a different type, such as, so how will they pass it to something else during runtime? Eventually, it is TypeScript code that got converted to JavaScript, right? If they had passed the wrong thing here, they have first passed it in TypeScript. Of course, if someone is going to the JavaScript code and modifying it, then of course you can run into this issue. But usually you convert TypeScript to JavaScript, you run JavaScript. You never modify your JavaScript code by hand. So if there is any type errors, they will happen during this TS to JS conversion. All right. Hopefully that answers your question. What is the most for a company that open source their code? What is the moat for? Moat is they have licenses. So you can't really do anything with your code base. Anyway, it's very hard to understand someone else's code base. Nothing is hard to create these days. Anything you want to create, you can write the code for. So someone open sourcing their code bases isn't giving out anything that you cannot anyways do. So no one's losing their moat. And if companies really have a moat, they don't open source that moat. Should we use interfaces only when we want to enforce a functional implementation? Something similar to method overriding. Something similar to forcing method overriding. Enforce a function implementation. Should use interfaces and types for function implementations. What is the second thing? Something similar for enforcing method overriding. This part I don't understand. What do you mean by something similar to enforcing method overriding? Can you tag me on Discord after this with a more elaborate this question a bit? Someone posted some code related to Zod, which also I will cover in the offline video. Why don't you make config file or constant file for the same in different components? Why don't you make config file or constant file using the same in different component? I don't understand this question. I am using GitHub Copilot, helping a lot, syntax auto completion. Question is, if I have the logic clear in mind, is it advisable to use Copilot? Yeah, if you understand, if you can write that code yourself, then use it. Otherwise, try not to use it. In production real life, do programmers use Copilot? So I haven't. Unfortunately, I have not used it. I use it for simple syntax, auto completion, things like these. I don't use it for all logic. I probably should use it. I don't think there's any downside. It'll hamper learning. Yes, that's the only downside. Okay, you won't ever be able to code this yourself if you're just pressing tabs all around, which is fine. I don't think there's any downside unless you want to be an independent coder who can code without an AI. If the Wi-Fi is down or if AI stops becoming a thing, then it makes sense. Learning phase may avoid it as much as you can. Because you'll be like, I understand this tab, Don't do it for some time. Eventually do it. When you can write code very fast yourself, then use it as much as you want. I was able to do interface user number or string. Oh, you can do that. You can do this. Interface user number or string. This is not an interface. You cannot do number interface number interface. Here you cannot do whatever number or string. This has to be a type if you're defining it outside, but if you're defining it inside here, then you can do whatever you want. You can do number or string. Yeah, that's fine. This you can do. Yes. All right, that covers all the questions. If you have more, especially 2 people I asked to tag me on Discord. So would urge you to tag me on Discord with the question, elaborate it a little bit more. And Baki, I'll cover a few more extra things that I have learned also and the things that are left in the offline video. I will see you guys next week where we will do Postgres and Prisma. Let's see how much we can do. I also have videos from the last cohort that I can probably post so you can warm up. With that, let's end it, guys. I will see you guys next week and in the offline video. Bye bye kar do. Neend aa rahi hai? Yahan pe to nahi aa rahi, bro. It's just 5 p.m. here. So I'm out for some, I don't know, do something. MSGS Anant, if you did that, ask for a bounty. We'll get you a bounty. Let's do like $25, all right? I'm in Paris. Answer nahi diya. Rikshit, what was your question? React bundlers, what about them? Do you want me to cover them? Happy to cover them in an offline video. Please take a break of 2 weeks. 1 week bhi nahi, bab re bab. Paris vlog, we'll see. Paris for some work. There's some, these I have to take, what do you call them? Events I have to take, and then there is NFT Paris next month. All right. Cool, guys. I will see you guys next week. Bye bye.